And now we will continue our EKG series, and in this video, we'll talk about the R wave. Just to remember, guys, that R wave is actually representing the ventricular depolarization, meaning that when the ventricle contracts, will give me the R wave. R wave, generally speaking, should be a narrow complex, and when we say narrow complex, meaning that the total width from the beginning of the QRS complex to the end of the QRS complex is less than 3 small squares. If it is larger than or it's wider than 3 small squares, it's called broad complex. And this is really very important because when we will classify tachycardias, it will depend on the QRS complex duration. If it is narrow complex, then the tachycardia will be called narrow complex tachycardia. While if the complex is really wide, at that time it will be called broad complex tachycardia. Generally speaking, if the electrical impulse or the action potential is being generated in the upper chambers in the left or right atrium, then they will go to the ventricle through the AV node and bundle of Hess, right? And this is actually the fast pathway that the electricity will just go all over the ventricles really fast because this is the normal anatomical electrical pathway. And if this is the case scenario, then the complex will be narrow because the electricity reaches the ventricle really quick. But if the focus of contraction happens in the ventricle, let's say like in the septum or the ventricle itself, the wall itself, then the electricity will travel slowly in the muscle because it is not following the normal conduction pathway. And at that point, the complex will be wider because the electricity took too much time to reach all over the ventricles. Okay, so this is the pathophysiology around behind the broad complex QRS complexes. Okay, let's look at this EKG strip here. Okay, and we can see that the QRS complex from its beginning to its end is almost like 2 small squares, which is normal. So this patient has tachycardia. This is narrow complex tachycardia. And I suspect that the cause is from here, from the toe atria, maybe from the SA node as well. While this EKG here shows that these QRS complexes are really weird. And if you can see, they are almost like 5 or 4 small squares, indicating that these are broad complex tachycardia. And in this case, we suspect that the focus is coming from the ventricle muscle itself, and this impulse is not following the normal pathway, the conduction pathway. And actually, this is diagnosed. You can simply diagnose the patient with a ventricular tachycardia that can be fatal. All right. Now, let's talk about R wave progression. Normally speaking, when we are looking at the V1 to V6, there is a normal pattern. So R wave are almost absent in V1, or it will be very tiny, as you can see here. This is the normal. I'm showing you the normal EKG. So normally speaking, when you are looking to the R wave, the V1 will have minimal detection of the R wave. Okay, and when you go to V2, it's getting longer. V3, it's getting longer. V4, almost they are equal to S wave. And after that, the R wave become more dominant. And in V6, almost the R wave is getting the longest, right? If this is in contrast to the S wave. If we are looking at the S wave here, it's really very large in V1. And when you go to V2, maybe it's the same thing. And after that, they are getting smaller. So you get every person will differ from the others. You get the idea, the trend of the waves. So if you look here, V1 is small, longer, longest. So this is a good R wave progression. Okay, so R wave start very small in V1 and it's getting bigger. Sometimes there may be some variation. It could be here very tall and now it's like shorter. But you get the full trend, the general trend of the R wave. So generally speaking, when you look at this EKG, it's getting it's getting taller, and the S wave is getting shorter. This is called, or smaller, and this is called actually the normal R wave progression. Okay, if we want to give an objective definition of R wave progression, we should say we look always at V3, In V3, it should be more than 4 or more small squares. 4 or more small squares. So if there is poor progression, meaning that the R wave is not getting longer as we go from V1 to V6, or V3, the R wave is less than 4 small squares. Let's say 3 small squares, 2 small squares, or even 1 small square. In this case, we can say this is a poor R wave progression. And whenever you have a poor R wave progression, you have to think about 2 things. Number one is prior MI, especially if the myocardial infarction is affecting or affected the septum, interventricular septum, or the anterior wall of the heart, because the conduction system is there, right, in the septum. So if the myocardial infarction happened and affected the septum, then the conduction pathway will be deranged and R wave progression will be poor. Number 2 is left ventricular hypertrophy. Okay, if the muscle is really large and large enough, the progression will be very, very poor, and you will find like in V1, like it will be large, here will be shorter, and the R wave progression will be not maintained. Okay, so always think about these two if you have a poor R wave progression. Now, let's take a picture of EKG that shows poor R wave progression. As you can see here, this is normal. This is very small R wave, but still small. Look here, still small, and now is recovering, right? So this is poor R wave progression. If we want to talk about objective assessment of that, look at V3. It is less than 4 small squares. It is almost only 1 small square. So this is a poor R wave progression. So this patient either have a prior MI, or this patient has a left ventricular hypertrophy according to the full EKG. All right. Now we talk about the indication and indicating what, and this is a very important information here. If there is total absence of R wave progression, so there is no R wave at all leads. So let's say like in V5, let's say there is no R wave. Okay, let's omit this. And in V6, let's say there was no R wave. If there is no R wave at all, absence of the R wave progression, that this is really very characteristic for dextrocardia. You want to make sure that the patient does not have a dextrocardia in which the heart will be going to the right instead to the left. Okay, so this is just to keep in mind about R wave progression. And thank you.